With code day 18. Let's go. Okay, so usually inverted coordinates. This is a common pattern this year. Okay. So top left corner. We need to reach the x in the bottom right corner at 70, 70. To simulate. Following, let's plan out where it would be safe to run. For now, so we use first few bytes falling into memory space. Sure. Okay. Just 12 bytes of the path from top of. This is just the same as 2 days ago, right? Sure. So this is our test. Have to be careful with coordinates. So coords is f dot read. Let's split lines. And we can actually go put split on the comma or x in this. Chords. Let's see if we read that correctly. Okay, let's make them int. Okay, now we can just, these are the places that we cannot go in. And it says the first 12 bytes only. So pass is chords, just the first 12. And the grid is just x, y equal 0, 0. So no, it's actually from hit to import hit push and hit pop, and q is distance is 0 and x and y, while q and is hit pop q it here your response is 1 0 0 1 0 minus 1 and minus 1 0. How big is the grid? I think it was 70 by 70. Yeah, so we do this. So we go for the x, dy in directions. If so we just do if x plus dx in range m and y plus dy in range m, and in this case we have to go the other way around, so y plus dy x plus dx not in 4, then we can go there. So do q dot, so we push q, here we have to start also the distance plus 1 x plus dx y plus dy, and we also need a scene set, and we just say that put x1 in there, and this will say and x plus dx y plus dy not in C. So we don't go back. We do this and scene.add. Oh, what the fuck's happening here? Oh, okay. Scene.add x plus dx y plus dy, and we print. So here we do if x y is equal to in this case it's going to be 1 and range 1. Then we just break, just make distance and break. Uh, uh, um, Test for dot add equal sync. Well, to car we add um, okay, so they're inverted. So also here they're inverted. So let's just say that green core, then we just change this thing as and this. We print this. So read and core. Okay, this looks, or there's an error here. Maybe it's 7 here actually. Okay, 22, sure. So let's a full example. Okay, let's just go for the full. So we don't need test. Ports you in ports. And this is yes, now it's 70. Actually 71. Oops. And yes, that's it. We need only the first. 250. Nice. You know how fast everyone needs to go. You need to determine the first byte that will cut off the path to the exit. Not going to be fast enough to make it to the exit before the path is completely blocked. To determine how fast everyone needs to go, you need to determine the first byte that will cut off the path to the exit. Coordinates of the first byte that will prevent the exit from being reachable from your starting position. Okay, so um, fine. Um, Okay, so now for yeah, it's actually 3ydx. Try to do, so we cannot get out if, what happens to the algorithm if we cannot get out? I guess the queue will still contain or add ydx. How many of them there are? Well, fine, we can do it. Let's maybe not print the queue to be faster. So we just add it. So what happens if we can't reach the end? I guess if we can't reach the end, if we don't break here, we just do 3.5. Let's see just how long does it take. Okay, so it's pretty fast. So let me think. If we can't reach the end, like we just need to basically we need to have at least one path that goes to the end. If there are no path, okay, so you just do it like this. We go code here. So we need MM4 and that's just it. And we're gonna return one here. So if we basically finish the queue without being able to go anywhere, then we return -1. Okay. So let's just try to do explore and explore of MM4. Science. Okay. So now we just do for bx by in check core.add bx by if explore and core equals -1 and bx y explore. Or we don't, wait, let's get rid of the print this thing. Alright, let's maybe fast enough. Nice. Okay, so this is a pretty standard advent of code problem. It's basically almost identical to what is it, day 16, I guess, which was still Dijkstra, with a little bit like a little twist, because here you could go in different directions. You could, like, turning was an action, but like just a standard Dijkstra problem. Like if you've never heard of it, you should definitely learn this algorithm for advent of code. It's just a graph, an algorithm where you just find the shortest path in a graph from each node to every other node. So you just given a route, for example, in this case 1, you just find the shortest path to each other node in the path in the graph. And related to advent of code, it's basically, you can see this grid is a graph where you can go at each point, you can go to every other neighbor which is not a non-valid position with a cost of 1. And this is why here we add 1 to the distance, so right here. And apparently the author of advent of code really wants a programmer to know about this problem, about this algorithm. And I mean, it's actually pretty useful also in interviews. These sort of algorithms often come up. I hope that in later days or in later years, maybe other interesting graph algorithms come out, like, I don't know, Floyd-Warshall or Bellman-Ford, these sort of algorithms, because Dijkstra has been pretty much always there. Every year you get at least one Dijkstra problem. And I mean, part 1 is literally just Dijkstra, nothing more. And in part 2, you just incrementally, like, since Dijkstra is pretty effective and is very fast, you can just, as soon as you find a solution, so you basically at every new invalid coordinate that you're given, you just add it to the invalid positions and run Dijkstra. And as soon as you find a solution, every time you just return a value. You just return 1, for example, and if you end the algorithm without finding a solution, you return -1. And basically you try to add every possible invalid position and just run Dijkstra. As soon as you get a -1, that's your answer. Okay, so see you next time.